Okay. Wow. Everybody's here. Number 16 is 9. Number 18 is 7. Number 20 is negative 12.2. 22 is 180 milliliters. 24 is about 6.86 hours.
Hey, Sean, on question 20, did you mean negative 12 and 2?
I did mean that, yes.
Yeah.
Number 26 is between 0 and 1.1 non-inclusive. 28 is between negative 4 and 3, also non-inclusive. Number 30 is x is less than 2. No, lies. X is greater than 2. It's between negative 2 and 1, non-inclusive. And x is less than negative 5. I would list those in the other order, but anyway. Number 32 is 6,250 at 9% and 3,750 at 5%. 34 is negative 1, and that's all we did. So what questions do we have?
28.
28. All right. 28 is 3/4 minus 1 over x minus 3 is greater than x over x plus 4. So, what should we do?
Get the least common factor.
Yeah. Least common denominator. What would it be?
It's 4 times x minus 3 times x plus 4.
Okay. And multiply it on the first one. What all cancels? Just the 4. So we've got 3 times x minus 3 times x plus 4. And then on the second one, what all cancels? The x minus 3, yeah. So minus 1 times 4 times x plus 4 is greater than. And then the x plus 4 cancels. So 4x times x minus 3. Now what? Distribute. Right. So on the first one, the 3 has to come down. X times x is x squared. It's going to be plus x, but x times 4 is 4x. Minus 3x minus 12. Minus 4x minus 16 is greater than 4x squared minus 12x. Right? Got some like terms happening over here. Times x squared plus x minus 12 minus 4x minus 16 is greater than 4x squared minus 12x. What now?
Distribute the 3.
Distribute the 3. Yeah, that's fine. So 3x squared plus 3x minus 36 minus 4x minus 16 is greater than 4x squared minus 12. Now what? Like terms. That guy and that guy and this guy and that away. So we bring down 3x squared minus x minus 52, right? It's greater than 4x squared minus 12. Now what?
Subtract 4x and add 12.
Yeah. Minus 4x squared plus 12 plus 12. We end up with negative x squared minus x minus 40.
Isn't that still 12x?
Yeah, it's 12x.
What 12x?
4x squared minus 12x.
Oh, yeah. Square.
4x squared.
You change it to. You changed it from 12x to just 12.
Oh. X, and X.
Yep.
So, try again. Negative x squared plus 11x minus 52 is greater than 0. Now what?
Take out a negative.
Take out a negative so that a is positive. So we've got x squared minus 11x plus 52 is greater than, no, lies. Is less than 0. We understand that flip and why it flipped.
You divided both sides by.
Divided or multiplied both sides by a negative, right?
Yeah.
So now what? We attempt to factor it. Sounds like a great idea.
It doesn't look very comfortable, but maybe it is.
What was this, 28?
Yeah.
According to the book, it is.
Huh. Boogie.
Oh, no, just kidding. According to the book, it isn't.
Aha!
Maybe. I don't know. Let's find out. What are the factors of 52?
52 and 1. Wow.
That is true. 52 and 1 is one option.
26 and 2. Yeah.
26 and 2.
13 and 4.
13 and 4. Do any of those work?
No. Nope. Not factorable.
So it doesn't factor. So now what?
We cry. No, we complete the square.
Sure, let's complete the square. Let's do it. So, move the 52 over. X squared minus 11x equals negative 52. Do the green part. Negative 11 divided by 2 squared. So 121 fourths.
Hey, Sean, wouldn't the equals 2 be less than or
I switched it. We're going to check our regions here in a minute and see what all works and what all doesn't work. Because it's easier to think about this way. This is just getting our critical points, right?
Yeah.
So, plus 121 fourths, plus 121 fourths. This left side is going to factor into x minus 11 halves squared equals, what is 52 times 2 times 4? A whole heap. I don't know. Negative 52 plus 121 fourths. Somebody do some math and tell me what the answer is. Negative 37 fourths. 87 fourths. Great. Now what? Square root both sides. I love it. Let's do it.
Wait, 52 plus 121 fourths?
Negative 52 plus 121 fourths.
Okay, that's what I do. Whoops.
Whoopsie, you silly goose. Oh, nice. You know what we should have done? You know what we should have done that would have saved us some time? It would have been real easy. We should have just done the discriminant. Done b squared minus 4ac. Discovered that we got a negative, and then we would have known there are no real solutions to this problem. So, we're not quite done. We're not quite finished. Because what do we need to check?
To see if x or the denominator.
Yeah. So we set this equal to 0. What am I doing? I don't know. Yeah. So 4 times
4 times.
x minus 3 times x plus 4 equals 0. X equals 3 and negative 4. Then we check a number here, we check a number here, we check a number here.
Oh, no.
And then we discover that it's in this region. Right? Where did you get it in your questing? So over there and you're like, oh, this doesn't work.
Kind of, and then I got it.
But you forgot about the denominators. Yep. Okay, number 20. Look, there's more people here. A few.
At least one more.
At least one?
At least one more. I mean,
No, a few.
we can't deny there's at least one more person.
I can deny whatever I want to deny. I don't have to speak the truth.
That's true.
That's not a requirement for living, as we can tell by looking at, television. People speak lies lots.
Yeah.
Often they yell lies as truths. Somebody's messaging. Who is that? Let's find out if it's one of our students. Mother of pearls. It is. The thing is frozen. Oh, well, thank you for telling me. Let's see if we can fix that.
Just the thing.
Yeah, the thing. Now it's moving and grooving.
The other day I actually started watching an Algebra 1 video, and then I was like, this is not the right video. I don't see Malcolm's head.
Well, there you go. Malcolm, you saved Landon some time and trouble. That's good.
Well, that's good.
All right, numero 20. All right, x over 2x minus 1
Wait, which question is this one?
plus 3 over
Oh,
x plus 4 equals 21 over 2x squared plus 7x minus 4. So, what should we do?
find the least common denominator.
Well, before we do that, what should we do? We should factor this denominator. I bet almost anything it factors into this times this. Let's check and see if I'm right. Haley's distracted by annoying middle schoolers. I would have eventually walked over there and closed it myself. So, thanks, Haley. Okay. Does that work? Is that how it factors? Negative. That would be 8 minus 1. Negative times a negative is a negative. Factors. Great. Now what?
Now we find the least common denominator.
Yeah, it's that. Great. On the first one, the x plus 4 cancels, so we're multiplying it times 2x minus 1. On this one, no, I did that backwards. How about times x plus 4? Yeah?
Sean, you're so silly.
Squared plus 4x.
Why would it be squared?
Because x times x is x squared. X times x plus 4 is what we're doing, yes. This one we are doing 3 times this one. And now we're doing 21 times 1. Then distribute the thing. And we end up with x times x equals x squared, and x times 4 is 4x, and 3 times 2x is 6x squared. 3 times negative 1 is negative 3 equals 21.
Sounded like an auction year.
Did I? Okay.
Combine like terms.
Combine like terms.
It's not 6x squared. It's just 6x.
That's true. Just trying to see if you were paying attention.
We weren't. Oh, no, wait.
A smoothie.
Kind of smoothie looks like that.
Smoothies that probably have like blueberries and stuff in it. I don't know. All right, like terms. This one and that one. And let's, for good measure, because we can, subtract 21 from both sides. Great. X squared plus 10x minus 24 equals 0. Let's see if it factors.
Yeah, it will happen.
12 and 2.
Yeah, 6 and 4.
6 and 4 doesn't work. Because in order to do 6 and 4, it has to be 6 plus 4, so positive times positive is negative. Is not negative. Yeah, so you have to use the 12 and 2 version.
That's a question.
Because then we can do minus and plus, and we get our negative at the end. Set each factor equal to 0, and we end up with x equals negative 12 and 2. Grand, glorious. Any questions on that one? Yeah, sure. Why not?
I would be okay with 26.
Thanks for your permission, Malcolm.
Do we have, we're not going to do like a note set today, right?
No, we are not going to do a note set today because we do have a test on Thursday, and this is the last lesson in the chapter.
Oh, yeah. Great. Hence the test.
And then we won't have homework.
Actually, you know what would be really smart that I didn't plan to do, but would be a great idea, is to do 9-1. Then you can have homework after the test. See, that would be smart.
Are you going to do that?
I might.
What time is it?
You know what the cool thing about that is, if we did that, 9-1 is easy. because it's review. What is this unit on? Vectors? Oh no, conics. Fun. That's what we're talking about in pre-calculus right now.
I don't like vectors. They're kind of annoying.
Vectors are awesome. You don't even know what vectors are, bro.
We did them in the last one, Algebra 1,
No, you didn't.
or Geometry or something.
You might have done a little bit in
Maybe
geometry.
it's not Geometry.
Vectors are cool. Number 20. 6. 22, 6. 5 over 3a.
Yeah.
Minus 3 over 4a. Is greater than 5/6. All right, what is the least common denominator?
12A.
12a, I agree. So, we'll do the first one, what's left to multiply?
4A.
Just 4. 5 times 4 is 20. When we multiply on the second one, what is left to multiply?
3.
3. 3 times negative 3 is negative 9. Greater than. What is left on the last one?
2A. Right?
2a. 2 times 5 is 10. Now what?
10A. Yeah, it's
10a is less than 11, right?
Divide by 10.
Divide by 10. A is less than 11 tenths, or 1.1.
So,
But
do you want the fraction, or would it be okay to do the decimal?
decibel's fine. The fraction's easier because it just spits out the answer. But we're not quite done yet, yes?
We have to plug it in and plug points.
Well, 12a has got to be greater than 0, which means a has got to be greater than 0. So we write that as a compound inequality. A is between 0 and 11 tenths. Or if you wanted to write it in integral notation, be 0 to 11 tenths, non-inclusive. Right?
Do you have a preference for which one you write this?
On this problem, no. When we're talking about domain and range in this class, we do it this way. All right. Y'all flip over to the study guide and see if there's any questions you have there.
Study guide.
Is this chapter 8?
This is chapter 8.
Oh, I turned straight to the study guide.
Wow.
I have one question.
Can we do one where we have to grade? You got to pick one. You got to be like number blank. Those ones are easy. You sure you don't want to do 8, 4?
Yes, that, yeah, 33.
Okay, sounds great. Number 33 from the study guide. So number 33 on page 583. We are supposed to, oh yeah, that's a good one. Because I feel like there's something in this lesson that we actually didn't even talk about. In this problem that we didn't even talk about, that I forgot to talk about. So that was a great option. Good job, Taylor. Way to pick it. F of x equals x squared minus 9 over, oh, actually, we don't have to graph this one, but still, it's a good one to pick. And then let's do like 37 or something. All right. X squared minus 9 over, I guess we could also graph this one, although this one's actually pretty easy to graph. X squared minus 5x minus 24. All right, what should we do, kids?
Factor both sides.
By sides, you mean top and bottom?
But yeah, both top and
I agree. Let's start by factoring. What would the top factor into?
X plus 9, or 3.
3 and x minus 3, because it's a difference of squares. That's absolutely accurate. The denominator factors x and x. 2 and 12, 6 and 4, 8 and 3. 8 and 3 sounds grand. 8, 3 minus and plus. So now what?
Cancel out the plus 3.
Cancel out the plus 3s. F of x equals x minus 3 over x minus 8. This is actually not quite as easy to graph as what I was thinking, but yeah. Okay. Now what?
Oh yeah, because we got to find.
We got to find some things, yeah? What things? Asymptotes.
And the values.
Yeah, so vertical asymptote. Does it have a vertical asymptote?
Yes. Wait. Yes.
Yeah, where is it? Or how do we find it?
We'll find
It is at 8. We set the denominator equal to 0, so x minus 8 equals 0, so it has a vertical asymptote at x equals 8. Great. Does it have any horizontal asymptotes?
No, I don't think so. Pretty sure.
What's the degree of the numerator?
2.
1. What's the degree of the denominator? 1.
Oh. Yeah.
There's no square.
So they're the same. What does that tell us about horizontal asymptotes? Go back to your notes if you have forgotten. And if you can't remember this right now, we probably should have started studying sooner, but like get on it today. Go look at your notes in the book, something. If they're the degree of the numerator is the same as the degree of the denominator, what does that tell us about horizontal asymptotes?
So, y equals leading coefficient of ax over leading coefficient of b.
Okay, so it has a horizontal asymptote at this divided by this.
1 divided.
So y equals 1 divided by 1, which equals y, which means that it has an asymptote at y equals 1. Great. It doesn't have any slant asymptotes. It's got a horizontal asymptote. You can actually have both in some, well, I don't know. This one has one more feature that we have not talked about. No, it doesn't have a slant. What? What? It has a hole. It has a hole at x equals what? Make a guess. Make a guess about how I know it has a hole.
3 or negative 3.
It has a hole at x equals negative 3. We're going to have to figure out what y equals there, but At x equals -3, it's got a hole in it. Okay? Because of this one that we have. So if you have a common factor in the numerator and the denominator, then there's a hole at x equals that number. That's going to be a point. All right, so it's got a hole at 3 something. We need to figure out what the something is. How do you think we figure out? Oh my gosh, question marks are hard. 3 something. How do you think we figure out where the something is?
Plug in 3 for that bottom.
Well, yeah, we find f of 3 here.
Not the above one.
Except it's not at 3, it's at -3, right?
-5.
What? F of -3 equals -3 minus 3 over -3 minus 8. So -6 over -11. So it's got a hole at 3 -6/11.
Or isn't it 6/11 because it's the negative divided by a negative?
Yes, positive 6/11. How did I get what? Because this one would make this a 0. So it's just that one factor equal to 0, basically.
Is it like specifically at that one point? And no
Yes. At one point, it has a hole.
Huh.
There's one place where this breaks down and the laws of physics get destroyed or something. I don't know. Right? So then if we were to graph it, we would graph our things. We would grab this. We would put a vertical asymptote at 8. 1, 2, 3, 4, 5, 6, 7, 8. And horizontal asymptote at 1. -3 6/11 is 1, 2, 3, and 6/11. So about a half-ish. It's got a hole right there. So this, and you could plot some points to figure this out, but it's going to look like, let's see, what would the it would have a intercept at +3, right? So it's actually going to cross right here and look like this. And then there's going to be another one up here, yeah? Something like that. You get some points and get that more accurate. But I would like to pause half a second and talk about what I mumbled, because it's useful in graphing one of these. I said that it has an intercept at, an x-intercept at 3. How did I know it had an x-intercept at 3? What did I do real quickly in my brain? What is y equal to at the x-axis? What? 0. All along. So if I set y equal to 0, then I would multiply all of this times 0. So all I have to do is set the numerator equal to 0. And if I set the numerator equal to 0, then I have my x-intercepts, right? So x minus 3 equals 0. Add 3 to both sides, and we'll get 3. So to find the x-intercepts, which can be very helpful, you just need to set the numerator equal to 0. And that'll give you your x-intercepts, right? It's another tool in your tool belt for graphing these. Makes sense? Easy peasy?
Not necessarily easy peasy, but it makes sense.
What was hard about it?
It's just a lot of stuff.
This is not a lot. Calm down. This is not a lot. Any other questions from the study guide?
37. Yeah.
37. Sure, 37. Let's do it.
Yeah, this is the one where we had to do the weird stuff.
Nah, it's not that weird. All right, 37. We're supposed to graph f of x equals x minus 1 over x squared plus 5x plus 6. So,
Factor.
yeah, sure, factor it. Why not? Factor the denominator, and we get,
3 and 2, positive 3 and positive 2.
yes, x and x, 3 and 2, plus and plus. And it's that one, not the 6 and 1, because the 6 and 1 would give us a negative,
And that would be bad.
and we don't want that, because it's all positive, right? We just talked about that in Algebra 1 on Thursday.
Factory?
Yeah, and that specific idea that the sign at the end has to match.
Did they hate it?
No, they haven't hated it. They thought it was pretty fun so far. They haven't been tested over it yet, so who knows? All bets are off. Okay, so now what? We factored, it's great, probably useful. What now? We need to find the asymptotes. We just did this, kids. Where do we start?
Start with
It doesn't matter, but how about vertical? OMG.
3, -2.
How do we find the vertical asymptotes?
Set the bottom stuff as 0.
Yeah, so the denominator equal to 0. X plus 3 times x plus 2 equals 0. We solve each one of those and we end up with x. We end up with vertical asymptotes at x equals -3 and x equals -2. Great.
Yeah.
Now what?
Horizontal.
Horizontal asymptotes. That's great. What's the degree of the numerator?
1.
1. What's the degree of the denominator?
2.
2. The degree of the numerator is less than the degree of the denominator. So what does that tell us about horizontal asymptotes?
It's magic.
Because this, A, or maybe it does exist.
Those are two of the options, yes.
And then if it's y, wait, y equals 0.
Y equals 0. Now it is specifically 1 less. Does that tell us anything? Or is it the 1 more? Go back and look at your notes. I am helping you study, but I would not recommend this being your only study time. I did warn you already that this is a chunk of a test. You're looking for slant asymptotes. What condition gives us a slant asymptote? At the top is 1 more, right? Not 1 less. So horizontal asymptotes, we have a horizontal asymptote at y equals 0. Great. It's not a slant asymptote. Is there any holes?
Isn't there not a horizontal asymptote? It's 1 degree less than the other one.
The numerator is, if the numerator is less than the denominator, look at that's like condition number 1-ish or something.
That's what I have written down.
If it's more than, there's not 1. If the numerator is more than, right?
Did I write it down wrong?
I don't know.
Maybe.
So you could also double check that by going back to 8.4 and being like, okay, what do they say? If the degree is less than the degree of the horizontal asymptote is at y equals 0. On the first condition, if the degree of the numerator is greater than the degree of the denominator, then there is not 1. So you might have written it down wrong. That's possible. Okay. So moral of that story is make sure you double check your notes with the book to make sure it does good things. Another tool that I neglected to tell you all about, y'all probably don't own a graphing calculator, most of you. There is a free one that's good for just like, okay, am I doing this right? That's more than just like photo math, although that's helpful too. But if you go to desmos.com, that's a great graphing calculator that you can be like, okay, yeah, is my brain thinking what my brain should be thinking, or is this a red flag and I wrote something down wrong, right? That's a great way to check it. Okay, so what should we do now?
Block some points.
What? I don't.
Or get some points on a.
I haven't even done any of this yet.
There's no holes. Slot the asymptote.
There are no holes. How do I know whether there's holes?
Because if something cancels out.
Yeah, because if we have a common factor in the numerator and the denominator, then you got a hole, right? Okay, so there's no holes. There's no hope. There's a horizontal asymptote right there. There's a vertical asymptote at -3 and -2. -1, 2, 3. So vertical one right here. And right here. We should use the tool that I just gave y'all. What's another quick tool we can get before we even worry about points? Well, it's actually going to give us a point, but no, the x-intercepts. So intercept or intercept. So how do we find the x-intercept?
Top equals 0. Set the top.
That top equal to 0. So x minus 1. X minus 1 equals 0. So we've got an intercept at x equals 1, so 1, 0, right? So one of our points is 1, 0. Great. That's helpful. Easy peasy lemon squeezy, which because that also can kind of help us give an idea of what this graph is going to look like. Possibly. Graph is going to look weird because it's got an intercept right there, but there's also an asymptote right there. So this is going to look weird. So what should we pick?
2, 3.5.
How about 0?
Yeah, 0.
So we can get that one. And then how about -1?
-2.5.
And we all definitely need -2.5. In fact, we probably need -2.25, -2.5, and -2.75. So we can see what in the world is going on in this little chunk, right? Where is he going?
Elsewhere.
We should probably grab like a -3 and a -4. That sounds great. We need some stuff over here, so like 2 and 3. Sounds great. Let's do it.
Wait, -3 is the asymptote.
Oh yeah, that won't work. How about -4 and -5? That's great. Hey, we're doing good. All right, so we put a 0 in there. 0 minus 1 is -1. 0 squared is 0, plus 0 is 0 over 6. -1/6. Zero, -1/6. So here, right? F of -1. -1 minus 1 is -2. -1 squared is 1. -5 is -4. Plus 6 is 2. So it equals -1. Okay, so we've got a pretty good picture of this part. We can probably even sketch in this little chunk. We're trending The limit is negative infinity right there. So that little chunk, we're going that way. Okay, what now? Negative 2.25. We've got the middle chunk. Did we do anything over here? Let's finish this chunk up. Let's do a 2 and a 3. F of 2. 1 over 2 squared is 4, plus 10 is 14, plus 6 is 20. 1/20th. So at 2, we're still very close to the axis. And then at 3, f of 3. We got 3 minus 3 minus 1 is 2. 3 squared is 9. Plus 15 is 24. So 30. So 1/15. So fractionally bigger. Right?
Basically like follow that.
Let's do something like way over here just to see if we're raising or if we're going to dip back down, right? Let's pick something, random. 20 sounds great. F of 20. 20 minus 1 is 9. Let's do 21. 21 minus 1 is 20. What's 21 squared? You have calculators.
21 squared? Wait,
21, yeah, I picked 21 because we get an even number on the numerator. Okay. What? 441 plus 5 times 21 plus 6. $552. Everybody agree?
Yes.
We divide both of those by 2 and we get 10 over something. 10 over 226.
538 is the most reduced form.
100 and
I got 546.
138.
sure.
For the not instead of 552. Wait, what?
552 divided by 2. 276. 5 over whatever that is. 138.
Great.
That number, is that number bigger or smaller than that number? Smaller. It's small. It's definitely smaller. So, what is the graph doing over here? Yeah, so it's going like, we probably, if we wanted to get like a really decent graph, we probably need to figure out like where the inflection point and where it starts going back down. So it's going to go up and then back down and never get closer. So it's going to go, it might, it's growing very slowly. So something like that, right? Great. So let's figure out. Honestly, there's not any more intercepts here, so let's just do one of those. Let's do negative 2.5. Sounds great. Then we can get it, because that's right in the middle, so it's going to be the vertex of like a parabola looking thing, right? We know how this works. It's either an S-curve or it's a parabola-ish, right? Yeah. And this one's definitely going to be a parabola because there's not any x-intercepts there. So f of 2.5. 2.5 minus 1 is 1.5. What is 2.5 squared? Negative 2.5 squared. So that means this is negative 3.5. True enough.
And then
what's negative 2.5 squared?
6.25.
Positive. 6.25 minus 11, right? Plus 6. Enter. And what do we get?
1.25.
What?
1.25.
What do we get? 6.25 minus 11 plus 6.
Yeah, 1.25.
Yeah, 1.25. Yeah, great. Negative 3.5 divided by 1.25.
Negative 2 point.
Negative 2 point what?
8.
8. So here and negative 2.8. 2.8. So it's going to look like this. Right?
Yippee.
Great. Now we need some stuff over here.
Negative 5.
Negative 5. F of negative 5.
Negative 5 minus 1 is negative 6.
Yes, it is. Negative 6 over. Negative 6 squared is 36. Oh, not negative 6. Negative 5 squared is 25. Minus 25 is 0, so it's over 6. So it equals negative 1, right?
Yeah.
So negative 1, 2, 3, 4, 5, and negative 1. So the dot is right here. Which means the graph is going to look like this. We did it.
Yippee.
Okay, y'all should leave.
Yeah.
Find somebody that loves you, and please, for the love of your grade and your sanity, study some.
Yeah. Studying is for winners.
Studying is for studious individuals, which may or may not turn out to be winners.